Welcome to the Deep Dive, where we take that stack of information you've got and really pull out those essential nuggets, those bits of insight just for you. Today, we're diving deep into a scenario that, well, could definitely hit your pager at 3 a.m. Or maybe more likely, show up as that really tough question in the senior DevOps and cloud engineering interview you're prepping for. So picture this. You've got this critical application, right? It's spanning multiple AWS regions, doing its thing, and then, bam, you start seeing these massive latency spikes between, say, your EU and U.S. environments. You're using AWS Global Accelerator, you've invested in Direct Connect for that solid link, and yet users are complaining, things are slow. So what's the very first thing you do? Either when you get that page or, when that question gets dropped in an interview setting.
Yeah, and what's fascinating here, like you said, is this isn't just some theoretical question. It's a very real-world problem. Happens all the time. Troubleshooting inter-region latency, especially with Global Accelerator layered on top of Direct Connect, it really tests your deep understanding of cloud networking. So we're going to show you not just, what the answer is, but really why each step matters and how it all connects to the bigger picture of cloud reliability and performance.
Okay, great. Let's unpack this then. The core interview question we're tackling today, just to state it clearly, is how would you troubleshoot inter-region latency spikes in an AWS Global Accelerator setup leveraging Direct Connect? And specifically, how would you incorporate VPC Flow Logs analysis?
Right. So for that quick kind of interview-ready summary, you'd want to explain that troubleshooting this kind of thing, this complex AWS setup, it really requires a systematic approach, like step by step. First off, you absolutely have to establish a performance baseline, know what good looks like. Then you meticulously diagnose the global accelerator configurations. After that, you do a deep dive into the direct connect side stability, capacity, all that. Crucially, you'd be using tools like a traceroute for path tracing, and you definitely need to inspect your network ACLs and security groups, don't forget those. And throughout this whole process, VPC Flow Logs act as your critical flight data recorder. They help you pinpoint where and why traffic is hitting snags. You're looking for patterns like sudden jumps in flow duration or maybe weird routing changes.
Okay, that's a fantastic high-level overview. Really lays out the map. But let's dig into the specifics now. When you say systematic process, what does it actually look like on the ground when you're in the thick of it?
Yeah, absolutely. So when you're approaching this problem, you need that methodical plan. First step, like I mentioned, is establishing a performance baseline. Honestly, before you can even think about fixing a problem, you have to know what normal looks like for your setup.
Right, you can't tell if something's slow if you don't know how fast it should be.
Exactly. So you use tools like AWS CloudWatch to monitor your typical latency, your throughput, and then, classic network tools like MTR and iPerf. They're great for baselining the normal latency and bandwidth between all your AWS regions and across those direct connect circuits. This gives you that solid reference point for when things inevitably go wrong.
Makes perfect sense. Baseline established. What's next? Where do you point your flashlight after that?
Okay, next up is the Global Accelerator diagnosis. Think of Global Accelerator as like the smart air traffic controller for your user requests, right? It's supposed to send users to the fastest, healthiest endpoint. So the very first thing you must validate is that your endpoint health checks are showing green everywhere in all your regions.
Ah, the health checks. Yeah, I can see how those can cause trouble.
Oh, definitely. A misconfigured health check, maybe it's too sensitive or not sensitive enough, it can inadvertently force traffic onto suboptimal endpoints. That causes these weird regional detours and, latency spikes. So you'd review your endpoint groups, your traffic dials, listener settings, basically making sure GA isn't accidentally sending traffic on a scenic route because it thinks the main highway is closed.
Got it. Check GA's brain, make sure it has the right information. Okay, what about the highway itself, the Direct Connect link?
Right, the Direct Connect deep dive. This is your dedicated private connection, your Autobahn, hopefully. Here, you need to really examine the BGP session logs. BGP, Border Gateway Protocol, that's how your network and AWS talk routing. You're looking for any signs of route flapping.
Reap flapping, meaning the routes are unstable, appearing and disappearing.
Precisely. Frequent BGP updates, or routes that keep changing age, that indicates instability. And that instability directly leads to delays while things reconverge, packet loss sometimes. It's bad news for latency. And, just as importantly, you have to verify that the physical direct connect links themselves haven't hit their limits. Check the utilization, the capacity. A congested pipe is always going to cause delays. No way around that.
Okay, so check the BGP chatter and make sure the pipe isn't full. Good. What's the next layer?
Next is path tracing. This is where you pull out good old traceroute, you run it from representative workloads, EC2 instances maybe, inside each region. The goal here is simple. Are packets staying on the AWS global network like they should? Or are they unexpectedly hopping off onto the public internet somewhere?
Ah, so you're checking if traffic is taking an unintended detour outside of AWS.
Exactly. If it leaves the AWS backbone, that strongly suggests a pathing or routing issue. Maybe a BGP route isn't propagating right, or something's misconfigured, sending your traffic on a much longer, slower journey. It's a classic thing to check.
Right, and often overlooked a bit. Finally, what about those network rules, NACLs, and security groups?
Yep, cannot forget those. Inspecting NACLs and security groups, you have to make sure that no network access control list, the stateless subnet firewall or security group, the stateful instance firewall, is like intermittently throttling or just dropping traffic. Sometimes rules put in for security can have unintended performance consequences. Maybe a rule is too broad, or there's a state table issue with security groups under heavy load. These can definitely introduce bottlenecks.
Okay, that covers the main components. Now, this is where it gets really interesting, especially for a deep dive like ours. VPC Flow Logs. You call them the flight data recorder. How do they become your eyes and ears in this scenario?
Yeah, this is where you get the granular details. So if Global Accelerator is the air traffic controller making decisions, VPC Flow Logs are absolutely the flight data recorder for your network traffic. They capture metadata about every single network flow going in and out of your VPC interfaces. Source IP, destination IP ports, protocol packets, bytes. But critically for us, the start time, the end time, and the action accept or reject.
Okay, so they log everything. When you're digging through potentially millions of log entries, what specifically are you looking for to find these latency spikes?
Good question. You need to look for specific patterns. The big ones are, first, spikes in flow duration. That's calculated from the start and end times. If you see the duration suddenly jump between certain region pairs or even specific subnets, that's your latency indicator right there. Path A is suddenly taking longer than path B. Second, look for bursts of rejected connections, or maybe flows with very few packets or bytes transferred followed by retries. This often signals underlying packet loss or perhaps network congestion, the connection failed. And third, watch for sudden routing changes. You might see traffic that used to go from source A to destination B suddenly start going from source A to destination C in the logs. That indicates traffic is detouring unexpectedly, maybe due to one of those GA health check fails or a BGP change.
And how would you actually query this? You can't just read the logs manually, right?
Oh, heavens no. You'd use something like CloudWatch Logs Insights, or maybe query them with Amazon Athena if you're archiving logs to S3. You'd write queries to filter, say, on action, AT-SEP-UT, and then look for flows where end time, start time is abnormally high, maybe grouping by source and destination IP ranges or ENIs corresponding to your regions. Or filter for action, rejects counts. That's how you spot the anomalies quickly.
Okay, that makes sense. Use the tools to sift the data. So we've dissected the troubleshooting steps and the power of flow logs. Let's zoom out a bit. How does all this connect to the bigger picture of architectural design? How do these different parts usually show their problems?
Right, connecting symptoms to causes. That's key. So if you see GA health checks causing issues like those endpoint reroutings or traffic taking weird detours, your global accelerator logs are the first place to look. And the action, usually it's about aligning those GA health checks with your actual application health, maybe using the same checks your ELB uses. Make sure GA knows the real story.
Okay, what about Direct Connect?
For Direct Connect instability, the signs are usually that BGP flapping we talked about, maybe CloudWatch capacity alerts firing on the link, or just general packet loss metrics looking bad. Your tools are the Direct Connect console metrics and, again, those BGP logs. The fix might involve getting your network provider involved, running tests on the physical circuit, maybe even needing to replace a failing cross-connect or something.
And routing issues.
Routing changes often manifest as those irregular paths showing up in traceroute or VPC flow logs showing traffic going to an unexpected region or AZ. Here, VPC flow logs and traceroute are your main tools for visibility. The action is usually confirming your BGP route announcements, what you're advertising to AWS and what AWS is advertising back are correct and propagating as you expect. Check those route tables.
And finally, just overwhelming traffic.
Yeah, traffic surges, sudden spikes in the number of flows, or the duration, especially visible in CloudWatch network metrics and VPC flow logs, can just mean you're overloaded. The solution here is often scaling more instances, bigger load balancers, Or maybe doing some load testing to really understand your breaking points before you hit them in production.
This really highlights how interconnected everything is. You can't just look at one piece. So thinking proactively, what should people be setting up before things go wrong? What kind of monitoring and alerting?
That's exactly the right mindset. Proactive monitoring is crucial. You should absolutely have CloudWatch alarms set up for your Direct Connect interface limits, like alert me when it hits 70% utilization, don't wait for 100%. Also, alarms for BGP session state transitions up-down flapping. You want to know about that immediately. And critically, whenever you do see a spike, your first step alongside the technical digging should be a change review. Ask, what changed recently? Was there a deployment, a network config change, a security group update? Correlating events in time is often the fastest way to the root cause.
That change review point is gold. So easy to forget in the heat of the moment. Okay, so we know what to check, but let's talk about how to think systematically to find that root cause. You mentioned a framework.
Exactly. Knowing the steps is one thing, but having a mental model for root cause analysis, or RCA, is another. A really effective combination is using something like a fishbone diagram approach mentally, combined with the 5 whys method. Let's walk through that example we touched on earlier, how it might play out.
Yeah, let's do it. Remind us of the scenario.
Okay, so the problem is latency spikes started hitting between the EU and US regions right after a weekend maintenance window. So you start asking, why? One, did Global Accelerator endpoints become unhealthy, maybe causing a reroute? And looking at the logs, yes, we see GA shifted traffic away from the primary US endpoint.
Okay, so GA did react. Why did it think the endpoint was unhealthy?
Good question. Why too? Why were the endpoints marked unhealthy? Digging deeper, we see the Direct Connect BGP session monitoring those endpoints, flapped it, went down and up again for about 3 minutes during the maintenance.
Ah, the BGP flap. So that caused GA to react. What caused the flap itself?
Right. Why 3? Why did the BGP session flap? We check the maintenance records, maybe talk to the network provider, and find out it was due to scheduled hardware maintenance on their side of the Direct Connect circuit. They had a bounce a port.
Okay, provider maintenance caused the BGP flap, which made GA failover. But you said it flapped for 3 minutes? Why wasn't the failover instant? Shouldn't GA react faster?
That's the crucial insight. Why 4? Why wasn't traffic rerouted instantly? We look at the Global Accelerator health check configuration and find the threshold was set to require 3 consecutive failures before marking the endpoint unhealthy and triggering the failover. That built in a delay.
3 failures.
Yeah.
Okay, and the final why? Why was that threshold set so high? Seems like you'd want it more sensitive.
Exactly the question to ask. Why 5? Why was the threshold configured that way? Talking to the team who set it up, maybe we find out it was deliberately set high to avoid false positives during very brief, transient network blips. They were trying to prevent unnecessary failovers, which can also be disruptive.
Wow. So the root cause isn't just provider maintenance. It's this interaction between the maintenance, the BGP behavior, and the specific GA health check tuning aimed at stability.
Precisely. That's the power of the 5 whys. It gets you past the immediate trigger to the underlying configuration choices and assumptions. And that leads directly to actionable best practices. Things like, always keep your GA health checks closely aligned with your actual endpoint application health. Proactively monitor BGP session age and flap counts, don't wait for an outage. Really use your VPC Flow Logs for spotting those region-to-region anomalies and correlate them with network events. And of course, have proactive alerting on link utilization and endpoint health status.
This has been incredibly valuable, really breaking down a super complex real-world problem into concrete steps and a way of thinking. So let's boil it down. For someone walking into that interview, or frankly, anyone facing this kind of issue, what are the absolute key takeaways?
Okay, to summarize the critical points, the things you really need to remember. First, tackling inter-region latency in this kind of setup demands that systematic, step-by-step troubleshooting approach. Don't jump around, cover your bases. Performance baseline, global accelerator, direct connect, path tracing, and those network security rules. Follow the layers. Second, leverage VPC Flow Logs as your primary diagnostic tool. They are invaluable. They give you that granular forensic detail on network paths, latency, errors. Think of them as your essential site data recorder. Learn to query them effectively. Third, always combine active, real-time monitoring with a methodical root cause analysis framework like the 5 whys. Monitor everything GA, Direct Connect, Flow Logs, but when something breaks, use a structured approach to find out why, not just what. And finally, prevention and proactive measures are key. Implement robust alerting for critical infrastructure health and utilization before things fail. And always, always conduct a change review when performance anomalies occur. What changed? That question can save you hours.
Wow, that was a fantastic deep dive. It is crystal clear that truly understanding these intricate relationships between services like Global Accelerator, Direct Connect, and knowing how to really wield tools like VPC Flow Logs, well, it's absolutely essential for anyone managing modern cloud infrastructure today. And for you, our listener, especially if you're prepping for that next big interview, remember this. Showing this kind of systematic thinking, this deep technical understanding, that's what will really set you apart. It's not about just listing AWS service names. It's demonstrating how you'd actually solve a tough real-world problem step by step. And maybe here's a final thought to chew on as we wrap up. Beyond just troubleshooting outages, how could you apply these same techniques? The detailed monitoring, the flow log analysis, that structured five-wise thinking, how could you use them proactively? Maybe to identify opportunities for architectural improvements, or perhaps even find ways to optimize cost by spotting inefficient traffic patterns. It's all connected, isn't it?
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.